Now let's talk about absolute refractive index of a medium and the physical significance as well as the factors on which it depends. So remember, whenever light travels from vacuum to an optical medium, or you can say air to an optical medium, because refractive index of vacuum and air are same, that means the speed of light in vacuum and air is same, which is 3 into 10 raised to 8 meter per second. So whether you say the light is traveling from vacuum to medium or from air to medium, both are considered as same. So here, whenever light travels from vacuum to an optical medium, the refractive index of that medium with respect to vacuum is called as absolute refractive index. So whenever light travels from vacuum to an optical medium, the refractive index of that optical medium with respect to vacuum is called as absolute refractive index. It is given by refractive index of medium with respect to vacuum, that means light travels from vacuum to medium. This absolute refractive index can be defined in terms of speed of light. So the refractive index of a medium with respect to vacuum, which is absolute refractive index, is defined as the ratio. It is defined as a ratio of the speed of light in vacuum to the speed of light in medium. So the speed of light in vacuum to the speed of light in medium gives you a constant because it is a ratio of two same physical quantity, that is speed. So the speed of light in vacuum to the speed of light in medium will always give you a constant value, which is nothing but the absolute refractive index of that medium, and it is simply written as absolute refractive index of medium. We don't need to specify V over here. If we simply write refractive index of a medium, we always talk about absolute refractive index. So absolute refractive index is defined as the speed of light in vacuum to the speed of light in medium. So mu of m can be written as C, which is the speed of light in vacuum to the speed of light in medium. From this formula we can clearly see that the refractive index and velocity, these are inversely proportional to each other. That means greater the value of refractive index, lesser will be the speed of light in that medium, or the lesser will be the value of refractive index, greater will be the speed of light in that medium. As we already know that light travels fastest in vacuum, so the refractive index is found to be least for vacuum, and for vacuum refractive index is taken as 1. And for any other medium, the refractive index value will always be more than 1. So absolute refractive index, remember, absolute refractive index will always be greater than 1, and for vacuum it will be equal to 1. From this formula I can also write mu of m is C by Vm. So V of m can be written as C by mu m. You can see these are inversely proportional to each other. If I give you the physical significance of refractive index, what is the actual meaning of refractive index? So this is very simple. Suppose if refractive index of a medium is mu, that means speed of light in that medium is simply C by mu. If I talk about glass, for glass the refractive index is 1.5. So what is the meaning of this statement? It means the speed of light in glass will be C upon 1.5. That means speed of light will be 1.5 times less in glass than the speed of light in vacuum. If I say refractive index of water is 1.33, that means the speed of light in water is given by C by 1.33. It means speed of light in water is 1.33 times less as compared to speed of light in vacuum. So whenever we talk about absolute refractive index, we always compare the speed of light of that medium with respect to speed of light in vacuum. And if I talk about the factors that affect the refractive index, so one factor is the nature of material of medium. So as glass, water, diamond, these are three different material medium. So all the three medium will have different refractive index. So speed of light in all the three medium will be different. Second factor is the temperature. As the temperature increases, the speed of light in that medium increases. So as the speed is inversely proportional to refractive index, So with increase in temperature, the refractive index will be lowered. Remember, refractive index is inversely proportional to temperature. This is just a relation. We don't have any numericals based on this value. Remember, refractive index always decreases with increase in temperature. The first factor is the nature of the material of the medium. Second factor is the temperature. Third factor is the wavelength of light. That is color of light. So as the color of light changes, so the wavelength changes. So what will change accordingly is the refractive index of that medium. I will give you a simple statement. We have studied formula V is equal to F lambda, and I have already told you that frequency of a wave never changes. With the change in medium, what will change is the speed, so will change the wavelength. So if a wave is traveling in vacuum, so C का value will be simply F lambda in vacuum. If a wave is traveling in a medium, the speed will be V and it becomes lambda in medium. So this refractive index mu of M, this C can be replaced by F lambda in vacuum to the F lambda in medium. Remember, frequency never changes for a given wave. I can cancel the frequency. So refractive index of medium is also wavelength in vacuum to the wavelength in medium. From here also you can say the refractive index is inversely proportional to wavelength. So refractive index depends on the nature of material of medium. It depends on temperature. It also depends on wavelength. But remember, it is inversely proportional to the wavelength. If I talk about VIBGYOR, that is spectrum of white light, in VIBGYOR, if I say in VIBGYOR, the wavelength of red is maximum, remember, and wavelength of violet is minimum. This is the value. Whenever you talk about VIBGYOR or spectrum of white color, violet has the least wavelength, so the refractive index of violet will be maximum, and red has got maximum wavelength, so the refractive index of red will be minimum. Remember this statement. So the absolute refractive index, we always talk about a ray of light traveling from vacuum to an optical medium. Thank you.